Okay, here's part C. Just stopping it around 5 minutes. What can we do here? Simplify this.
Well, we could try to simplify the powers, but there's no real end to the tower.
That's right. It doesn't end.
Mm-hmm.
Which seems like it's going to be make our life very difficult.
Yeah.
It doesn't end. So how can we use that to our advantage?
This is, well, I have some marker. Like, but the sum, if you start here, this is the same thing as if you start here, or here, or here.
Or where else?
Or, like, anywhere.
Aha.
If you start anywhere, you're always going to get the same sum. Like,
Not sum.
or product.
Not even really product.
But they're the same result.
The same result. If you start anywhere in that tower, it's infinitely long. You get the same result. So what does that allow us to do?
Well, if we start at the end, like at the very last x.
But there is no very last
Yeah.
X.
Yeah. So you've made a very interesting observation here.
Well, like,
That no matter where you start in this tower, the tower is infinitely high.
we can keep like taking off the ones that we don't need.
But
Like
there's
if we start here, we take off that, and then if we start somewhere up here, we take off all that.
Yeah? Good.
And you're
Good
taking,
thinking.
so it's infinitely high, but you're taking off infinitely many x's here.
Yeah.
So that's infinity minus infinity.
Yeah, so that seems to complicate things.
That says 0 equals 2.
Yeah, well, that's probably not true, right?
Yeah.
0 definitely doesn't equal 2. But you have a very interesting idea. No matter where you start in that tower, it's the same thing. So how can we use that idea?
Well, you can't say we can start at the last and say it's the same thing, because there
No.
is no last.
That's right.
There is no last tower.
So what can we do?
Yeah, where's a good place to I shouldn't say good place, but where's a different place we can start?
Like not at the bottom.
Yeah, not at the bottom. Where
We
might...
start at the second one.
Okay, so what would that mean if we
Then
started
we-
at the second one?
We took off the bottom X.
Okay, but it needs to stay there. We're not going to take it off. We're just going to start at the next one. Okay, what does that mean? Yeah.
But then we have an extra X.
Yep, that's true.
Well, this means you have. Let's see. So you have this sum,
Not some.
or this power tower here.
Okay.
This is 2. So you,
Wait, why?
because if you start anywhere, it's 2.
Oh,
So you have x squared. That's what you would get.
okay.
And then this has to equal 2.
Why are you looking at me? A little strange. What do you think? What do you think? Tell me what you're thinking.
Well, X squared is 2, but then that would mean X is the square root of 2.
Mm-hmm.
And X, the square root of 2 is between 1 and 2.
Okay. Once this can simplify to x squared equals 2, then we have x equals the square root of 2. That's interesting.
Yeah.
So instead of chopping off down below what you were doing before, instead we just keep going up. We say we start here and go up. But we already know what x to the x to the x to the x to the x is. What is it?
2.
It's 2. We already knew something about that.
Mm-hmm.
Okay? And so what does that mean? What does it mean?
Means this.
It means x squared, it must be 2. So x is...
It's the square root of 2.
Alright, well let's go into our calculator and see if square root of 2 seems to work, okay?
Okay.
Alright.